In this tutorial, I'm going to cover the making of my electric furnace. In the next video, I'll cover the crucible and the electronics when I get around to it. But I had a charcoal furnace, and I really liked the idea of melting metal and making anything, but the charcoal furnace was just so dirty, you couldn't do it inside. And then I found electric furnaces, which I liked a lot better, but I didn't really like any designs that I saw out there, so I decided to make my own. And this is my take on making an electric foundry. Like with everything, there are pros and cons. This furnace does not heat up very quickly. It goes up about a degree every second or two. To me, it doesn't matter because I can be out in my garage working on something else. I set the aluminum in there, 20 minutes later it's melted, I can pour. It's not a big deal for me. But if you are short on time, then you're probably going to want to build a gas or charcoal furnace, because you might just not have the time for this kind of design, waiting on it to melt and all of that kind of fun stuff. I really like the safety in my design of the furnace. I feel like it's a lot safer than some other designs that I've seen. I'll link a YouTuber named The Art of Weapons. He made a similar electric foundry with fire brick, but the way he wrapped the coils around really kind of made me nervous, because if a coil fell out and you're messing around with it, I always recommend, you turn the thing off. But if you're collecting slag off the top and you touch it, you're not going to have a good day. You're probably going to die. It's 220. That's why I like this design better, because the coil is a lot less likely to just fall out. I still definitely recommend that you go watch this video. It's really educational, and it's really more high quality than my videos will ever be, so I would definitely go check that out. I'll post it in the description. Now, let's get on with the tutorial. The first and most important thing you'll need for this furnace is called ceramic fiber. I bought 25 feet of it for $100. You may say, wow, $100 is a lot, but I can make about 5 to 7 furnaces with this amount. Ceramic fiber is the heart of the furnace. Every layer, including the layer that holds the coil in place, is made of it. The only part of this furnace, the refractory part of this furnace, that isn't made of ceramic fiber is the base. Next, I had to choose an enclosure. I chose a 6-gallon steel bucket. I bought it at Lowe's for around $10. To get the 220 to the coils, I used stainless steel bolts and porcelain insulators. The length of the bolts was about 4 inches, but the diameter will vary based on what kind of porcelain insulator you get. They're not all the same. For the electrical side, I bought a cheap uxcell steel coil. I also bought a cheap Chinese thermocouple. I don't know if that's going to work out. And I bought a Inkbird PID controller and solid state relay. You're also going to need a length of 220 wire, however much you need to get to where your furnace is going to be. You're also going to need both corresponding connectors. I'm not an experienced electrician, but I do know that 220 is not a joke, and if you don't know how you're going to have to wire it, please consult an electrician or someone who knows what they're doing, because 220 will kill you. I will be including how I wired my connectors, but don't go off my information, because I am not any type of electrician or electrical engineer. Please do your research on these connectors and be as safe as possible when working with them. I also added a voltmeter with amperage and watt hours to my furnace. This allowed me to know if the furnace was on, just as a double check, and also how much energy it used. It can also tell you if your coil is broken. My enclosure for all high voltage components, including the relay and the incoming 220 connections, are through an AC disconnect box. This is basically a breaker that allows me to turn on and off the 220. I'll leave a spreadsheet in the description with all components you'll need to complete this project. So to start the project, you need to make a 2-inch mark from the bottom of the bucket, and this is going to be where we put the refractory sand mixture to keep the heat in from the bottom. Go ahead and grab your plaster of Paris, sand, something to mix it in and a mixing tool, you're probably going to have to use your hands in the end to get all the clumps out. I tried to use the lid of the bucket to contain the sand and plaster when I was pouring it, but I didn't really think it out. Just try not to make too much of a mess. You're going to end up making a mess anyway and having to clean it up. I used 12 cups of plaster and sand and 8 cups of water, and I ended up having a little bit less than I would have liked to extra. It ended up being fine. It filled to the 2 inches, but it wasn't as much as I'd like it to be. I'm going to go ahead and say start with 8 cups of water and 15 cups of plaster and 15 cups of sand. And you'll have some extra left over, but in case you spill or anything, you won't have to worry about not having enough, and that's just no fun. Go ahead and move the plaster and sand into whatever you're going to be mixing it in. I just used a 5-gallon bucket, but anything should work as long as it has enough volume. Don't add the water yet, because the water will activate it, and then it's just going to go downhill from there. So wait till you've thoroughly mixed it up dry first, and then add the water. As you can see, I kind of skipped this step, and it just made it a little more difficult to mix. I started mixing with a paint stirrer, and then I just went ahead and did it by hand, because it's the easiest that way, because you can feel the clumps and it's a lot easier to work with. To my knowledge, you can't over mix this unless you run out of time. So just mix it until it's a even consistency and it's the same color. When you pour this, make sure you're on a level surface and shake it as you go so the plaster settles down and you're not getting inconsistencies in the height, because it is a pretty thick mixture. But I actually had to scrape the side of the 5-gallon bucket. I was mixing it in because I almost ran out, so I definitely recommend adding some more. And once you get to the line, let it set on a level surface, and really within an hour it should be set enough to work with. You can smooth the surface while it's drying if you want, but it's not a huge deal. This was what was left in the bucket. It looks like a little more than there was actually on camera, but it's definitely close. To start cutting the ceramic fiber, you can download or print this template that I made in the description. This should give you every dimension you'll need to make the cuts, and they all should line up perfectly. I recommend reading the MSDS sheet for ceramic fiber. It's not a super dangerous substance, but I will tell you it's itchy, and my dad is somehow immune to it, so I had him do a lot of work with it. The tools you'll need for cutting the ceramic are a straight edge of some kind, a square, a tape measure, a marker, and a utility knife. I tried using vinyl cutting scissors, but I find that a razor or utility knife is a lot more controlled and does a better and cleaner job. If you're curious, this is what my roll of ceramic fiber looks like. I recommend putting it on a table of some kind because the floor does get it a little dirty. After you set it all out on the table, then you want to measure and mark the 4 templates in the most efficient way, depending on the dimensions of the ceramic fiber you get. This might be especially important if you don't have a lot of room to make mistakes, like if you bought a small amount of fiber. After you've double-checked your measurements and you know they're right, go ahead and cut it with a utility knife. That's what I find is the easiest. And you should be left with 4 pieces that fit perfectly into the furnace. If they take a little bit of work to fit in, don't worry, because after you fire it up the first time, like you see in this furnace, they weaken up quite a bit, and it's a lot more malleable to work with. The next step is to work on the lid, which doesn't really have a template, because all you have to do is press down with the lid onto the ceramic, and that gives you an imprint of what it looks like, and then you can just cut around it. You're going to need to cut 2 layers for this because heat does rise, and this will just make it a little more insulated. I found that with one layer I would sometimes get burned by touching the top if I didn't have my gloves on. Later I'll show an optional step of drilling a hole in both sides and running a wire through the ceramic because sometimes it does fall out. Now you're probably wondering, well, how is a coil going to go in there? You're going to have to remove the innermost layer now, after you've made sure that it fits, and we're going to have to start the process of adding the coil to that layer now. After you've removed the inner layer, download or print out this template that'll show you where you need to make the cuts for the coil to fit properly. I recommend that you put the pattern you see on the right on a piece of wood or other straight edge, so that you have an idea of what spacing the opening needs. This will be even more helpful if you have a different length of coil. This is another design of the inner layer that I had before I did some calculations to get it perfect. This was the first one. It was handmade, and you can see that the stick at the bottom that I put the pattern on definitely helped in spacing the openings and the gaps. Cutting out the ceramic with something like a hobby knife should be reasonably simple. In this case, a chisel blade is very helpful because you can go straight down and it's just better overall. A razor blade will work though. Next, wrap the ceramic with the cutouts around something about the same diameter as the inside of the furnace, and this will keep it together while you're installing the coil. This part is definitely helpful to have people around while doing, and this is wrapping the coil around the inside slots. It's not very fun and it's tedious, and this is when you might end up breaking the ceramic, so be careful. Next, surround it with newspaper or something similar, just so that it slides easier into the ceramic. This may take a little bit of work, and it's again is a pretty tedious process. Just be careful and don't break the fiber. And please unwind a bit of the coil at the end, or you'll have a bad day trying to unwind it at the bottom of the furnace. I know from experience. Now get your porcelain electrical insulators and your stainless hardware, and we're going to have to drill a hole in the side where the two coils are, the ends of the coils. And we need to then connect the coil over the bolt and then tighten the nuts on both ends so that they are completely secure and they won't fall off. Also, make sure you support both sides during this, as to not twist the coil and break the end of the coil as you twist the outside connectors. And make sure not to use ordinary steel bolts, or this will happen. Also, make sure you connect the ground to the side of the bucket. In case the 220 does hit the bucket, it should blow the breaker, which should stop it from killing you. So now, if 110 is applied here and here, the coil will be glowing at full 220 volts. But it's not as simple as adding two hots to both ends. They have to be on the two sides of the breaker. The most simple way is just to wire another breaker into your house for 220. But like I've heard other people say, you can add an extension cord from one side of the house on a different side of the circuit to the other, but I don't recommend this. And right now, if you wanted, this furnace would work with a crucible that fits inside. It would be a dumb furnace, so it wouldn't have temperature regulation, but as long as you could turn the coil on and off when it got too hot or wasn't melting, then you should be able to melt metal. But in the next tutorial, I'll explain how you need to hook up a PID controller, a relay, and a thermocouple all to work together to keep the furnace regulated at the temperature you want to melt the metal you want. If you operate it manually, there is a pretty big chance that you will end up melting the coil, which isn't a good thing considering you put all that work into getting the first one in. And also, if you didn't notice, if you touch any of those two connectors on the side for both 110 circuits, you're probably going to die. So that's also something I'll address in the next tutorial, making it a little more safe. And really, after you add the relay, the PID controller, everything does get safer, because I'll also end up adding a breaker that I can turn the 220 on and off without having to go to my house's main circuit breaker. One of my biggest fears with doing this tutorial was that it wouldn't be quality content, it wouldn't be easy to follow, and I just hope that's not the case and you guys enjoyed it. If you decide to build this furnace, just please be safety and always wear safety squints. Don't get pensed.